My name is Serina Franzen for Algebra 2, 6th period, and I'll be doing this video lesson over the properties of logarithms. Now, today we're going to be going over three different properties for logarithms: the product property, the quotient property, and the power property. Now, logarithms are used in place of large, massive numbers or really, really tiny numbers because they're easier to work with and easier to move around. And I'm expecting that you know the basics of logarithms already since we're just going over the powers today. So we'll start with the power product. Now, the power product is mainly used for when you're adding two logarithms. And so for this equation that I have, the simplified equation, it's log base b of x times y equals log base b of x plus log base b of y. And to put this in more simplified terms, when you have when you're adding two logarithms together, you take this number and you take this number and you times them together if, and only if, these two bases are the same. So if the bases are the same, you can add them together, but if they're not, like if it's the log base 3 of 14 plus log base 4 of 6, this cannot be added together because this is a 3 base and this is a 4 base. Only when they're the same base can they be added together. So for a bit of a number example, we have log base 9 of 4 plus log base 9 of 6. Now they both have the same base of base 9, so they can actually be added together. So, as we said before, you take your two numbers here. We have 4 and we have 6, so you do 4 times 6, which equals 24. And when you're writing out your combined logarithm, what you do is you do the log of base 9. We're using base 9 because the base of 9 was used in both of our previous ones. They could be added together. So they come together for 9 of 24 because 4 times 6 equals 24. And that's the basics of the product property. So we'll move on to the quotient property. The quotient property is very similar, except it's using division and subtraction instead of multiplication and addition. For this one is used when you have a subtraction sign for two logs. And similarly, this one is log base b of x divided by y equals log base b of x minus log base b of y. In more understandable terms, when your bases are the same as they are here, you take your first term and divide it by your second term. So in this, as it says over here, x divided by y. And again, this can only be used when the bases are all the same. So for our number form down here, we have the log base 2 of 36 minus log base 2 of 12. Now, since they both have a base of 2, it can be subtracted. And so all we have to do is we have to take 36 and divide it by 12, like this. And that gives us 3. So we have log of 2, because the 2 carries over just like it did over here. Log of 2, log base 2 of 3. There we go. So these two are very similar, except this one is using subtraction and division, and this one is using multiplication and addition. So it's pretty easy to figure out which one you'll be using. Now for the power property, this one is even easier because it's very, very different from the other two. So this one is log base b of x raised to the power of n equals n log of base b of x. This one, it may look complicated, but it gets a lot easier. Now the first thing you probably notice is we have a lot of crazy numbers here. We have a b, we have an x, we have an n, and then the n magically teleports. So this one is actually quite easier to comprehend than the other two, but it just looks a lot more difficult. So for this one, again, your base will stay the same, but we're not adding or subtracting anything, so it's only the logarithm that you have right there that's changing. So all you have to do for this is you have to take your n and you just put it at the front of the equation. What this means is that it's the exact same. If your x here is raised to a power, it's the exact same thing as if the logarithm was being times by that number. So this is basically n times log base b of x. So to put this in a more understandable format, because numbers are so much easier than variables, we have the log base 3 of 14 raised to 6. Now, if you look as before, the n will magically transport to the front of the equation, over here, so it becomes 6 invisible times the log base 3 of 14. These equal the exact same thing. Now just to reiterate, all of these things can be used when you're using either very, very large numbers or very, very small numbers because they're easier to use than thousands and thousands of zeros. It's the same idea as exponents. And addition, these were actually created to simplify division and multiplication into addition and subtraction. And if you look on your note sheet, there's a little history blurb about that you might find kind of cool. So thank you for watching this video. Bye-bye.